So can you hear me, guys? Good evening, guys. Welcome to the class. So today we are going to study set relations and functions. And we are going to do some of the JEE questions which have appeared in the past years. Hi, Mihir. Hi, Govinder. Good evening, Shreya Kumari. Namaskar, Varsha. So I believe most of you have studied functions, but do you know that we have a very good practical application of the functions chapter, especially in our day-to-day lives? So guys, how many of you have traveled in Ola or Uber? Good evening, Ankit. So I'll show you one practical application of what basically the function is all about. Okay, guys. So let's say, okay, for those of you who haven't traveled, you must be knowing that what exactly the concept is all about. The function is basically a machine. You send one input and you get output. Now, if I want to explain, let's say we have Ola, fare. Okay. So what goes as the input? The distance which you traveled. So let's say the distance which is traveled is going as the input. And what comes as the output is the fare which we need to pay. Okay, so the values of distance which you can put into the Ola function will be the domain, and the values which come out as the fare will be my range. Okay, so I'm just assuming a random function. Let's say fx is equal to, let's say 25 plus 6x. Okay, now what all values of x can I take? I can take the values of x starting from 0 till infinite. So distance can be basically be taken from 0 to infinite, because the distance traveled cannot be negative. So it will basically start from 0. Now, what will be the values of my fare? If I put the minimum possible distance, that is 0, so fare will be 25 rupees. So the minimum value will be 25. And again, okay, Mihir, why 0? Because the distance cannot be negative. So if I say a practical example of 0, let's say you book a cab and you just sit over there and then complete the ride. So just the distance traveled is 0. So it will go into the function, it will put the value of x as 0, and the fare calculated will be 25. Now, the values of fare will be from 25 to infinite. So what's my domain? My domain is from 0 to infinity. I can say that domain is equals to 0 to infinity, and my range is from 25 to infinity. So I'm sure you guys must be pretty clear with the concept of domain and range. So we can move forward to see through some of the questions in the IIT exam which have appeared in the previous years, making use of the concept of domain and range. So moving very back into the 1983s, 1980s practically, where in a simple question was asked, which was saying that find the domain of the function, which says that 1 upon log of 1 minus x to the base 10 plus square root of x plus 2. So practically we have two simpler questions with us. Now, if you know that anything which is written inside the square root cannot be negative. So first of all, we will see that under root x plus 2 has to be like x plus 2 has to be greater than equal to 0, because anything written inside square root cannot be negative. So x plus 2 has to be greater than equal to 0. So guys, x has to be greater than equal to negative 2. So this is one of the thing which we have with us, which is x is greater than equal to 2. Now we'll be moving toward the second function, that is 1 upon log 1 minus x to the base 10. Now, if you know the property of log, log says that you can't keep any negative value inside p. That is, log does not take any negative values. And it also doesn't take 0. So practically, I want log of 10, 1 minus x should not be equal to 0. Why? Because if it turns 0, then my new, like, it will be 1 upon 0. So 1 upon 0 is not defined. So at what point will this give me 0? For that, the term which is written inside log has to be 1. So basically 1 minus x should not be equal to 1. Either you can take 10 to the right hand side, it will become 10 raised to the power 0. So basically x cannot be 0. So this is second thing which is available with us. Okay, we have two things. X will be greater than negative 2 and x should not be equal to 0. Now still we are remaining with one thing. That one thing remaining is that term which is written inside the log should be greater than 0. So we'll be solving that part as well. We have to say that 1 minus x has to be greater than 0. So if I take minus x to the right hand side, I'll be having 1 is greater than x, or basically x is less than 1. So I believe many of you are getting what exactly my answer should be. If I combine these three things, x should be greater than minus 2. So if I draw the number line, guys, and see what all values are satisfying with me. So if I draw my number line and x has to be greater than minus 2. So from minus 2, it will move over here. And we are having x is less than 1 and x is not equal to 0. So that's, like many of you have already predicted, the option C. Here comes the next question for the domain. Now in this we have a log and a quadratic function. Again, quadratic is on the denominator. So whenever there is something in the denominator, we want denominator should not be equal to 0. So our first constraint is x square plus 3x plus 2 should not be equal to 0. So basically, it's a quadratic equation. At most, it can have two real roots. So we will figure it out what those two real roots are. So if I do the middle term splitting of this, so that will be x square plus x plus 2x plus 2 is not equal to 0. So I have x into x plus 1 plus 2 times x plus 1. So this should not be equal to 0. So basically x plus 1 and x plus 2 should not be equal to 0. Now how this is possible? When x is not equals to -1 and x is not equals to -2. So basically, two of the values are removed. X is not equals to -1 and x is not equals to -2. Now coming back to our numerator, which is log x plus 3 to the base 2. Now, if you see log of x plus 3 to the base 2, we want x plus 3 to be greater than 0. So x plus 3 should be greater than 0. Plus 3, moving it to the right hand side, we'll be having x is greater than -3. Okay, if we have x is greater than -3, so this is also one thing which is to be taken into account. Now combining these two, so x is from -3 to infinity, and we do not have -1 and -2. Okay, Ayush, I'll repeat it again for you. See, Ayush, there were like two things which had to be taken into consideration. One was the denominator cannot be 0. So I found out the roots of the two, like the quadratic equation available in the denominator. That was x squared plus 3x plus 2. So x is not equals to -1 and x is not equals to -2. So this is one thing. The second thing is, like, anything written inside log has to be greater than 0. So x plus 3 has to be greater than 0. So plus 3 moving on the right hand side will become x is greater than -3. I believe, Ayush, this must be now crystal clear to you. Great. So we have D option with us. Now, moving on to the next question, which appeared very recently in the 2011. Okay, now guys, we have a function with us, one condition with us, and a modification of function, which is involving another variable y. Now, if you see, guys, fx plus y is equals to fx plus fy plus xy. And both of them, x and y, belong to real numbers. The thing to notice is x and y belong to real numbers. So now we'll be start doing plugging in the values in order to satisfy or basically bring out the values of a, b, and c individually. As soon as we have the values of a, b, and c individually with us, we can very easily find out the summation. Now, what can I see is if I put x equals to 0 and y equals to 1, now that will be something which is solvable with me. So let's put x equals to 0 and y equals to 1. So if I put these two things, what will I get? So into the function which is given to me. So this was the function given to me. Fx plus y is equals to fx plus fy plus xy. So f of 0 plus 1 equals to f of 0 plus f of 1 plus 1 into 0 is 0. So what we are left, we have f of 1 is equals to f of 0 plus f of 1. Now f of 1 gets cancelled off. So we are getting f of 0 is 0. So f of 0 is 0 for me. Now this is something to be taken into account. Now fx is also equals to ax square plus bx plus c. If I put x equals to 0, a and b will be eliminated and I'll be left out with c. So if I put f of 0 over there in the definition which is given above in this one, okay, so if I put f of 0, I'll be getting a into 0 plus b into 0 plus c. So that's practically equivalent to c. Now, if I make use of the above two equations, which says that f of 0 is 0, and the second one speaks about f of 0 is equals to c. So we can conclude that c equals to 0. From these two, we can conclude that c equals to 0. Okay, so if we have c equals to 0, now what? Now we are going to do something interesting again. Okay, I know the value of f of 0. I need to bring f of 0 again into the expression. So what can I do practically is I can put y equals to minus x in the green one. Okay, I'm putting y equals to minus x. Why? Because again, I'll be ending up with f of 0. That will help the question look very easy. So f of x minus x is equals to f of x plus f of minus x, and plus xy will be equals to minus x squared because y equals to minus x. Now on the left hand side, we are having f of 0 and f of x, you know that, is equals to ax squared plus bx plus c. So I have ax squared plus bx plus c, and f of minus x will be plus of ax square because negative square will be positive itself, minus bx plus c minus x square as it is. And we know that f of 0 is 0 from the equations above. Now see what simplified. B is eliminated and we have ax square plus ax square is 2ax square and c is already 0. So we have minus x square equals to 0. Now if I try to solve this, what will be I getting? I'll take x square as common and I'll be getting 2a minus 1 equals to 0. So basically 2a minus 1 equals to 0. So a will be equals to 1 by 2. We have got another value with us. That is a equals to 1 by 2. Now, Now we look back to the question. We haven't made use of one of the things, that is a plus b plus c equals to 3. So we'll now make use of this particular expression, a plus b plus c equals to 3. And we know the value of a and c. So a is equals to 1 by 2 and c is equals to 0. So we'll just plug in over there. So a plus b plus c equals to 3. So a is equals to 1 by 2. B, we need to find it out. And c is 0. So this is 3. So basically that will give me b equals to 5 by 2. Now we have got the all three values of a, b, and c. Okay. So now our question was summation n equals to 1 to 10 fn. Okay. So it was summation n equals to 1 to 10 fn. Okay. Now guys, if you know this property in summation, if you are, this is the iteration variable. If it is n and if I change this to x, nothing is going to change. So it will remain as it is, summation of x equals to 1 to 10 and summation fx. Okay, now what is fx? Fx is equals to ax squared plus bx plus c. So this will be equivalent to summation of x equals to 1 to 10 of ax squared plus bx plus c. We know the values of a, b, and c. So this will be equals to summation of x equals to 1 to 10. A is what? A is 1 by 2 and b is 5 by 2 and c is 0. So a is 1 by 2 x square plus b is 5 by 2 x plus 0. Now it will break down as a rule of summation. Summation of a plus b can be broken down as summation a plus summation b. So this will turn out to be summation of half will come out, constants come out of the summation x square. So 1 to 10 plus 5 by 2 summation of x. So from 1 to 10. Now, these are the direct formulas. I believe everyone knows this. Summation of x squared is x into x plus 1 into 2x plus 1 upon 6. And summation of x is x into x plus 1 upon 2. So this will be 1 by 2 into summation of practically if I write directly the formula. So this will be x into x plus 1 into 2x plus 1 upon 6 plus 5 by 2 into x plus 1 by 2. Now, in order to find, I have to just plug in the values of x as 10. That will be 1 by 2 into 10 into 11 into 21 upon 6 plus 5 by 2 into 10 into 11 by 2. So guys, if you solve this, this will come like 330. So that's a simple calculation, guys. If you solve this, you'll end up getting 330. So we'll be having A as the option. So the main thing to learn from this question was, whenever we see a function being a very complicated question, So just try to think and plug in the values. And in 99% of the cases, 0 and 1 are really helpful. Just think and revolve something around 0 and 1. We just plug in 0 and 1. So that was able to solve our question. So the thing to remember is just make the help of 0 and 1 while plugging in the values of the function in order to get approach. Now, guys, we'll be coming to the next part of types of question, which talk about 1 1 on to like that. So what's 1 1? 1 1 is something for one particular input, you are having one output. So basically, two different inputs will not give the same output. So if I explain this thing graphically, what basically 1 1 and onto stands for. So if I draw a simple graph for you guys, okay, let's say I draw a simple curve like this. Okay, now if you see, there are two such values in this function which will be giving me the same output on the y-axis. Let's say these 2 points are having the same y coordinate. So let's say one of them is alpha and one of them is beta. So this function is not 1 to 1. Why? Because it's two values alpha and beta are giving me the same output, that is y over here. So this is not 1 to 1. So it's basically many to 1. Now the approach which has to be used while finding the 1 to 1 function is that you have to see whether the function is strictly increasing or the function is strictly decreasing. So for that, if you remember, we used to find the value of f dash x. If the value of f dash x is always positive, that means the function is always increasing. Okay, and if f dash x is negative, that means the slope is decreasing, and which is eventually resulting in function decreasing. So we will look into the f dash of this function and check it out whether it's always positive or always negative. If it is not, then obviously it's not a 1 1. So let's find f dash x. F dash x is equals to 6x squared minus 30x plus 36. So what I'm able to see, if I take 6 common, x squared minus 5x plus 6. So if I do the middle term splitting, that will be x squared minus 2x minus 3x plus 6. Then we have 6 into x into x minus 2 and minus 3 into x minus 2. So we have 6 times x minus 2 into x minus 3. Now if you see, if I do the wavy curve plotting for this, so basically between 2 and 3, x equals to 2 and x equals to 3, if I put a value more than 3, this will be positive. And if I take a value between 2 and 3, it will be negative. And if it is less than 2, it will be again positive. So f dash x is changing its sign. That means the function is increasing, decreasing, then again increasing. So we can say that it's not a 1 to 1 function. As soon as we see this, option A is eliminated because it's saying 1 1. Option C eliminated because it's saying 1 1. Now we need to check the onto. Now what's onto, guys? Onto means that the code domain, if I say what's basically codomain. This is my codomain. So codomain has to be equivalent to the range of the function. Now, what are the possible points that can give the maximum and minimum value for this function? The starting points f0, f3, and the points wherein it changes, because f dash x is 0 at maxima or perhaps the minima. So we'll be checking the values of fx at the crucial points 0, 2, and 3. So 3 points we'll be checking. If we are getting anything outside 1 to 29, we will be very sure to say that the, or if it is like not crossing practically 29, if it gets stuck somewhere around 27, 28, then also we can say that the codomain is not equal to the range. So let's find f of 0. So f of 0 will be equals to, so 2, and so that will give me 1. And f of 3 is what? So if I'll put 2 into 27 and then 15 into 9 minus plus 36 into 3 plus 1. So that will be equivalent to 28. And if I find f of 2, so that's 2 into 2 cube 8 minus 15, 460 plus 72 plus 1. So that will be 29. Okay, now guys, as you can see, the 3 crucial points are giving the value between 1 and 29 itself. So my codomain is equal to range. We can say that the function is onto. So we have the answer as B. We have codomain equals to range. So that resulted in my answer. Okay. Now guys, coming to the last question for the day, which is again a function, a very popular kind of function which came very recently in the 2017, which says that fx is equals to x upon 1 plus x square. Now guys, this is something very interesting. I have to find whether it's invertible, injective. Injective means the function is 1 to 1, and surjective means it's onto. So let's see whether it's 1, 1 or not. So guys, I was thinking something. If I put instead of x as 1 by x, what will I get? Let's see. If I put f of 1 by x, so that will be equal to 1 by x upon 1 plus 1 by x square. If I take the LCM, so that will be 1 by x upon x square plus 1 by x square. So that's nothing but the function itself, because x will go up and I'll be having x upon 1 plus x square. Now guys, you can see that function is not a injective. Why? Because it's not 1 to 1. See, fx is equals to f of 1 by x. So actually it cannot be invertible as well. So it's not injective. So our B option is eliminated. Now we will find the range of it. So for finding range, we'll be using the traditional technique, wherein we'll be writing f of x is equals to y equals to x upon 1 plus x square. I'll take the term on the denominator to the left hand side. So that will be y plus yx square equals to x. Bringing x on the left hand side. So it's converting into standard quadratic, yx square minus x plus y equals to 0. Now x has real values, so the discriminant of this quadratic has to be greater than equal to 0. So basically the discriminant will be minus 1 whole square minus 4 y square has to be greater than equal to 0. So 1 minus 4y square has to be greater than equal to 0. If minus 4y square is taken on the right hand side, we'll be having 1 is greater than equals to 4y square. Or basically I can write it like this. Y square is less than equal to 1 by 4. So that will convert into y square minus 1 by 2 square is less than equal to 0. So basically y will be lying between minus 1 by 2 and 1 by 2, as we are able to see in the one of the options. So our codomain is range. So we can say that the function is surjective, but it's not injective. Why? Because f of x was equals to f of 1 by x. So guys, these are some of the things which we learned. That first of all, you should remember the concept of plugging in the values in the good questions of functions, especially 0 and 1. That makes the question really very easy. And for more such wonderful tricks, guys, please stay tuned on Meritnation, and you will be helping with your upliftment of your JEE score. So guys, bye bye, take care, and have a great day.